In this video, we are going to talk about when polygons are congruent, what that means by definition, and getting into the importance of a congruence statement. So first off, the definition of congruent figures is two figures with exactly the same shape and size, meaning that all of their corresponding parts are equal. So all of their lengths and all of their measurements are going to be equal to each other. So when we take a look here, here's some examples and some non-examples. So here we've got a square, it's just rotated, but we see that all the sides are still marked congruent to all these ones, all 90-degree angles. Okay, this hexagon is congruent to this one. You see all the same markings. On these two trapezoids, you see that this side is marked congruent to this side with 2 tick marks. Okay, this one is marked congruent to this one with 3 tick marks. All the side ones are congruent. And then it's got the same angle measures. So look, we've got the one arc touching the red side and same thing down here. Okay, so all the corresponding parts are equal. In these non-examples, we see that this circle is smaller, so those aren't congruent. Okay, different markings on these triangles, and you can see that this one is longer. A 5-pointed star versus a 6-pointed star, definitely not congruent. So then let's talk about congruence statements. So congruent statements, and this should have an equal sign here. So a congruent statement looks like this. It's got an equal sign with a little squiggly above it. And so the way that you would read that out loud would be triangle ABC is congruent to triangle DEF, meaning they're all exactly the same shapes and sizes for their corresponding parts. So these triangles are already marked up that way. So if you have markings on the picture, you can definitely look at the picture to help you decide what parts are congruent. Okay, if you do not have markings and you have a congruent statement, you need to go from the congruent statement. This is such a big deal, okay? It tells the reader what is congruent. So when we take a look here, okay, we've got angle A, angle B, and angle C, okay, from the first triangle. So we have angle A, we're gonna figure out what that's congruent to, angle B, and angle C. So what are they congruent to? So if you take a look in this statement, so you can look at the picture, angle A has 3 arc marks. The one on this side that has 3 arc marks is angle D. But look at the congruent statement. So angle A is the first letter, D is the first letter. B is the second letter, E is the second letter. So angle B is going to be congruent to angle E, because they're both in the second position. And if you look at the picture, 1 arc in each angle. And then C is the third letter, F is the third letter. So angle C is congruent to angle F. And you'll see in the diagram, angle C has 2 arc marks and angle F has 2 arc marks. So then we need to get the sides. Okay, so then we'll take a look at the sides. So we've got side AB here. So which side goes with side AB? And if you look here, AB is the first 2 letters, DE is the first 2 letters. So that means that segment AB is congruent to DE. If we look at the congruent statement again, let me get rid of some of this stuff so it's not so confusing. Okay, if we take a look at the congruent statement for side BC, so that's the second and third letter here is EF. So BC is congruent to EF. And let me highlight that on the picture for you too. BC, 2 tick marks, EF, 2 tick marks. So then the final side that's left is AC. So if we look here, AC is the first and last letter, so that's going to go with DF. So that means that AC is congruent to DF. Okay, so you just pull them from the same spot. So whatever spot matches in the congruent statement, that's what they're congruent to. Then let's take a look at some properties of congruence. So we've got reflexive, symmetric, and transitive to talk about. You've seen them before in middle school. Reflexive property is that anything equals itself. So anything equals itself. So if we're going to use reflexive property here, triangle ABC would be congruent to triangle ABC itself. Symmetric property is if A is equal to B, then I can put the B first, and that's going to be equal to A. So you can switch them over the equal sign. That doesn't matter. So it could be x equals 5 or 5 equals x. Same thing. So if I'm looking at this sentence, it says if ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC. You can switch the order. Transitive property. So transitive property says if A equals B and B equals C, then ultimately A equals C. Since they are both equal to B, they have to be equal to each other. So with these triangles down here, if ABC is congruent to DEF and DEF is congruent to JKL, then ABC, okay, they're both equal to the blue one, they're both equal to DEF, so that means ABC would be equal to JKL as well. So what's this going to look like when we start using it with geometry, okay? So we end up with the reflexive property is the biggest one that we'll see, okay? So reflexive property we will see a lot in shapes. And what happens is a lot of times our shapes are going to be just, they're not going to be two different colors like this, okay? So we'll just end up seeing black lines here instead of red and blue. So your drawing will look like this more, okay, without the color. And so what we want to do is figure out which segments in that diagram are congruent, okay? And what happens is there's one that's drawn on twice, or one that's in both triangles, okay? So there's one segment in this drawing that's in both the red triangle and the blue triangle. So that is the segment BC. So BC is in the red triangle and BC is in the blue triangle. It's the exact same segment. Even though it's in both triangles, it's the exact same segment, so it's definitely congruent to itself. So over here, look for the one that's drawn in both trapezoids. So this middle piece right here, CF. So we would say CF, the red CF, is congruent to the blue CF by reflexive property. So if we were to split these out, because we'll start trying to prove that things are the same size and need to know how to justify it. So then in this parallelogram, we see the middle segment is BD that is in both triangles. So BD is congruent to BD by reflexive property. And often then we'll mark it on the diagram with a tick mark in there. And if there were already tick marks in other places, let's say that there was tick marks like this. So we've already got 2 sets, then this one would get 3 to say that that middle piece is congruent. All right, let's use this congruent statement idea that we just got. You're going to have to do a bunch of this in your homework. So check out the congruent statement because, again, it's not marked on the picture, so you need to go by the congruent statement. So triangle SAT is congruent to triangle GRE. So in fact, we could just cover this up. I'm just going to cover up this diagram so that you're not tempted to use it. I just want you to use this statement. So angle S is congruent to what? Okay, so then you look in the congruent statement. S is right here. It's the first letter, so it's going to be congruent to the first letter in the other one. So angle S is congruent to angle G. Angle E, that's the last letter. Last letter is angle T. GR. Okay, so GR is right here, first two letters with first two letters. So SA. AT. So AT are the last two letters. RE are the last two letters. EG, first and last. So first and last. So EG would be with TS. Angle R in the middle with the other middle A. And then let's take a look at rewriting the whole triangle. Okay, so this one says ERG, so go in the right order. So which one goes with E? So which letter goes with E? That's T, so that's going to get written first. Which one goes with R? R is in the middle. A is in the middle. G, which one goes with G? G is here first. It goes with S. For the last one, R. R is in the middle. A is in the middle. E is the last letter. T is the last letter. G is the first letter. S is the first letter. So you just get them written in order like that.